Hello, welcome to Accounting Hub. I'm Professor George Scarpin, PhD in Accounting, and our topic today is how to perform a hypothesis test for population proportion. If you're looking for a hypothesis test for population mean, that is the t-test, this is not the video, but we have a video about it, and the video is in our video description. And for population proportion, we have the z-test. So how do we do that? So a hypothesis test regarding the population proportion is based on the assumption that the sample proportion is approximately normally distributed. So assume that the population proportion P is equal to the hypothesized value of the population proportion in the new hypothesis. So I want that my students get a grade of 90% of my exam, on my exam. So this 90% would be the P0. For instance. And first, we need to find the z-test. And the z-test, we cannot find it on Excel formulas. So we need to do it on hand. So we will be copy and paste this formula to our Excel. And how do we do that? We find the p-value. There are tons of ways, but the easiest way on Excel is to find the p-value similarly as with the test about the population mean, but we use z for proportion rather than t for mean. So here, how do we do that? So we find the critical value rule or the p-value. So critical value, we compare with our alpha and then upper test, lower test, or upper tail test, lower tail test, or two tail tests, or we can work with the p-value where we have here the upper, lower, and the two tail. On Excel, it's much easier to work with the p-value. Critical value, you need the stats table, and we don't have the stats table on hand usually, so p-value is much easier. We compare with our alpha. That is, alpha is usually 1, 5, or 10%. 10% is the less reliable, 1% is very, very much reliable. The average or the middle, that is what we usually work, is 5%. Okay? So what do we have here? And then the p-value is twice the area to the right of z here. But on Excel, we have it done. So that's easy. So how do we find on Excel? We have three formulas. Lower one tail test, norm.z.this, z, and true. Upper 1 minus the same formula. And then I will be explaining you later why. And for two tail, 2 times 1 minus normal this absolute z, because z can be positive or negative, so we work with the absolute number, and true, and all of them here are true because we want the cumulative number. Here we work with this cumulative area instead of a single area. So let's go to our Excel, and remember, the Excel file is free and the link to download it is in our video description. So here, this satisfaction rate, 4 or 5 stars, of a product sold by Scarpin Corporation, my fake company, is expected to be at least 80%. So a marketing problem here. A local store collects data from 500 customers and finds that 382 gave 4 or 5 stars to the product. Is it representative of the not total population of the expected number? Okay, just like a real class. Perfect. So first, we need to find the z. So here, population 500, 4 or 5 stars, 382. So we have the proportion. And what is the proportion? 382 divided by 500, 76%. And the P0, that is the, remember the P0, hypothesized value of the population proportion is 80. And to find z, minus 2.0246. Let's do it together. So equal P minus P0 divided by square root P0 times 1 minus P0 divided by N minus 2. And Z, remember, can be positive or negative. How do we know that? If our proportion is lower than the hypothesized, it will be positive. If here it's for 84, then it would be positive. Okay, so here, so first of all, the two-tailed test. I want to know if our proportion here is equal to the expected number. So it is two-tailed test. I reject it if it is lower or greater than our 80%. So okay, it's equal. The null hypotheses are different. And then the p-value. So let's work on this p-value and let's double check if it will match. So equal 2 times 1 minus norm dot s dot dist absolute z, where is z? Here, and true. 0.04. So 0.04, and here we are working with the alpha of 5%, so our significant level is 5%. So if you go to 100 stores, it will be valid for 95, for instance. 0.04, so we reject it. So the average is different. However, let's go and check if it is lower. So lower one-tailed test. Why lower? Because the z is a negative number. If z is a positive number, then it goes on upper one-tailed test. And that's why the upper, we have this 1 minus here to flip the number. Okay? So what do we have here? Equal norm dot s dist z negative 2 and true. 0.02. So yes, we reject easily then this one, because here we are looking only for the lower level. Okay, so that is, so yes, we reject this new hypothesis that is equal or greater, and okay, so it is definitely lower than 80. If our number here is 400, 395, then we fail to reject because, okay, it's quite close to 80. Okay, but let's keep an eye here. Okay, guys, so that's it. Thank you so much for watching this video. Questions or comments, leave it here or email me at jscarping@gmail.com. Have a very nice day and God bless you.